Today we are going to see question number 11 from 10.2. The question is prove that the parallelogram circumscribing a circle is a rhombus. You have to prove that parallelogram circumscribing a circle is a rhombus. So let's take it. So we have a parallelogram that is circumscribing a circle. That means the four sides of the parallelogram will touch the circle. Say A, B, C, D is the parallelogram, and the parallelogram ABCD is touching the side AB is touching the circle at P, BC at say Q, CD at say R, and AD at S. And what you have to prove? You have to prove that the parallelogram is a rhombus. So given is what? ABCD is a parallelogram. ABCD is a parallelogram circumscribing a circle. Now the side AB, BC, CD, and AD touches the circle at P, Q, R, and S respectively. To prove what ABCD is a rhombus. Now to prove ABCD is a rhombus, you have to show all the sides equal. So we'll try to show all the sides equal. Okay, proof. Now, if you see the figure, this AP and AS are just like two tangents from the same external point A. AP and AS are two tangents from the same external point A. So AP and AS will be equal. AP and AS will be equal. Same way BP and BQ are just like tangents from the same external point B. So BP and BQ will be equal. Same way CQ and CR are tangent from the same external point C. So they will be equal. Again, DR and DS are two tangent from the same external point D. So DR and DS will be equal. So we know that, we'll take it. Now when taking, we know that ABCD is a parallelogram. So the opposite side AB and CD are equal. So all the parts of AB and CD, we'll keep all the parts of AB and CD on the left side. The parts of AB and CD are what? AB, parts of AB are AP and BP, parts of CD are what? CR and DR. Okay, so first we'll take AP equal to AS. Then we can take BP equal to BQ. So I'm taking the part of AB, that is AP and BP on the left, and other thing we are taking on the right. Same way, all the part of CD, I'm going to take it on the left. So what I can take, CR equal to CQ, CR equal to CQ. Again, same way, DR equal to DS, DR equal to ds. We can mark it 1, 2, 3, 4, and why they are equal? Tangents from same external point to a circle are equal. So I can take them equal. Now after taking them equal, what we'll do, we'll add this for equation. We'll add this for equation. Okay, since I need space, I'm going to drop the first part. Now, what I'll do, I will add this for equation. So adding 1, 2, 3, 4. We'll get, and how to add the equation? We'll add the left hand side with the left hand sides and right hand side with the right hand sides. So all the left hand side added together, AP plus BP plus CR plus DR equal to AS plus BQ plus CQ plus DS. Okay, now on adding, we're getting this, but if you see nicely in the figure, AP plus BP is what? AP plus BP is what? AP plus BP is AB. So instead of AP plus BP from the figure, I can write AP. Same way, CR plus DR is what? CR plus DR is CD. From the figure, CR plus DR is CD and equal to, same way, AS plus DS is what? AS plus DS will be AD plus BQ plus CQ is what? BQ plus CQ is BC. So we're getting this. Okay, so on the left hand side we got AB plus CD, on the right hand side we got AD plus BC. Now we know what the opposites of the parallelogram are equal, so AB and CD are equal. Again, same way, AD and BC are equal. So what you can do, instead of CD, I can write AB because AB and CD are equal. And instead of BC, I can write, instead of BC, I can write AD. Why? Since BC and AD are equal. Why? The opposite side of the parallelogram are equal. So the reason will be since ABCD is a parallelogram. ABCD is a parallelogram. So what are you getting? 2AB is equal to 2AD. So I can cut this to 2. Okay, I will need space, so I'm rubbing again the portion that is written below. Now, what is left? AB equal to AD. We can mark this one as 5. So we got AB equal to AD, AB equal to AD. So we got the two adjacent side equal, AB and AD equal. But we know what AB is equal to CD and AD is equal to BC. So we know it, so right way, but we know what AB is equal to CD and AB equal to CD and AD is equal to what? BC. Why? We can mark this one as 6 and this one is 7, and the reason is why, since ABCD is a parallelogram or the opposite side of the parallelogram are equal. So we can just write since ABCD is a parallelogram. Okay, now what is shown in 567, AB is equal to AD, but AB is equal to CD also, and AD is equal to BC also. That means what? From this three equation, we can take all of them equal. So from 5, 6, and 7, what you can take? AB is equal to BC is equal to CD equal to AB. And since all the sides are equal, therefore what you can take? ABCD is a parallelogram. ABCD, sorry, ABCD is a rhombus, not parallelogram. Since all the sides are equal, ABCD is a rhombus. Okay, then we'll see the next question. Not the next question, question number 13. What is question number 13? Prove that the opposite side of the quadrilateral circumscribing a circle subtends supplementary angle at the center of the circle. So you have to prove that opposite side of a quadrilateral that is circumscribing a circle subtends supplementary angle at the center of the circle. So here also we have a quadrilateral that is circumscribing a circle. That means four sides of the quadrilateral will touch the circle. And what you're going to show is the opposite side of the quadrilateral subtends supplementary angles. Okay, let's take it. Let's draw a figure. Say A, B, C, D is a quadrilateral. Say O is the center of the circle. And the quadrilateral is circumscribing the circle. That means four sides of the quadrilateral will touch the circle at four different points. So side AB is touching the circle at say P, and BC at say Q, CD say at R, and AD at. And what you have to show is the opposite side. Say AB and CD are opposite side. They will subtend supplementary angle. That means you join the vertex with the center. So the angle subtended by the side AB will be AOB, and the angle subtended by the side CD will be what? COD. And you have to show that sum of these two angles are 180. The opposite side subtends supplementary angle means what? The angle subtended by the opposite side, if you take the sum of them, it will be equal to 180. You have to show that angle AOB plus angle COD is 180. Again, same way, the opposite side AD and BC subtends angle AOD and BOC. So you have to show that AOD plus BOC is 180. Okay, so let's write the given. A, B, C, given A, B, C, D is a quadrilateral circumscribing a circle with center O. Here we have the center, so we'll mention the center. Then the side AB, BC, CD, and AD touches the circle, touches the circle at P, Q, R, and S respectively. And to prove what? Angle AOB plus angle COD equal to 180, and angle AOD plus angle BOC is equal to 180. Okay, to prove this, we need construction. Construction will join OP, Q, R, OS. Okay, so construction is join OP, OQ, OR, and OS. Now, on drawing the construction, see the angle AOB is divided into two parts. This is one part, we'll mark it angle 1. This is another part, we'll mark it angle 2. Same way, angle COD is divided into two parts. We'll mark this one as angle 3, and this one as angle 4. Again, same way, angle AOD is divided into two parts. So this part, say, we'll mark it as angle 5, and this part we'll mark it as angle 6. And BOC is also divided into two parts. This part we'll mark it as angle 7, and say this part we will mark it as angle 8. Okay, now I need space, so I'm going to write the given and to prove. Then we'll start the proof. Okay, proof. Okay, first of all, if you say AP and AS are tangent from the same external point, and tangent from the same external point subtends equal angle at the center, so they will subtend equal angle at the center. So 1 and 5 will be equal. Same way, BP and BQ are tangent from the same external point, so they will subtend equal angle at the center. Same way, CQ and CR are tangent from the same external point, so they will subtend equal angle at the center. Again, DR and DS are tangent from the same external point, so they will subtend equal angle at the center. So what you can take? You can take angle. We can take angle 1 equal to angle 5. Again, angle 2 equal to angle 7. 1 and 5 are the angles subtended by two tangents from the same external point, so they will be equal. 2 and 7 are tangents. 2 and 7 are angles subtended by two tangents from the same external point, so they will be equal. Same way, 3 and 6 will be equal. Same way, 4 and 8 will be equal. You can mark it 1, 2, 3, 4. And the reason is tangents from same external point to the circle subtends equal angle at the center. Tangents from same external point to the circle subtends equal angle at the center, so they will be equal. Now, after showing that, if you see nicely, if you add up all this 8 angle, it will make a complete round. Angle 1, 2, 3, 4, 5, 6, 7, 8. If you add it up, it is making a complete round. So sum of all this angle will be a complete angle. So we can take their sum equal to 360. All this angle are making a complete round. So if you take sum of all this angle, it will be equal to 360. So we can take it what? Angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5 plus angle 6 plus angle 7 plus angle 8 equal to 360 degree. Isn't it big? Complete. Okay, now first we are going to show AOB plus COD equal to 180. Now in AOB the angles are 1 and 2, and in COD angles are 3 and 4. So we'll leave this 1, 2, 3, 4, but 5, 6, 7, 8 are not angles of AOB or COD. So what are you going to do? We'll change them. So leave 1 plus 2 plus 3 plus 4 as it is. And since we don't need 5, 6, 7, 8, instead of 5, what you can write? You can write angle 1 from 1. Instead of 6, what you can write? You can write 3 from 3. Instead of 7, what you can write? 2 from 2. And instead of 8, I can write 4 from 4. And we are doing the changes from 1 to 3, 4. So from okay, now after changing it, now let's look at the figure. Instead of 1 plus 2, I can write what? Instead of 1 plus 2, I can write AOB. Again, instead of 3 plus 4, I can write what? COD. Plus again, instead of 1 plus 2, I can write AOB. Plus instead of 3 plus 4, I can write what? Angle COD equal to 360. Okay, now AOB, how many AOB? 2 AOB. And COD, how many COD? 2 angle COD. Now we can take 2 common, so what we get? Angle AOB plus angle COD equal to 360. Now we're going to find AOB plus COD, so leave AOB plus angle COD and take this 2 to the other side. Where did it go? It will go down. Got it? It is 180. So what are you getting? Angle AOB plus angle COD is equal to 180. So we are showing AOB plus COD equal to 180. Now, in the same way, what you can show? We can show AOD plus BOC also 180. Now, exactly the same thing only, but while showing AOD plus BOC 180, we are going to change 1, 2, 3, 4 because we don't need this. So we'll change 1, 2, 3, 4, and on solving it, we'll get it. Angle AOD plus BOC is equal to 180. Now, exactly the same thing we're going to show, so we'll not show it, we'll write similarly. If we need to show exactly the same thing, we don't show, we just write similarly. Similarly, angle AOD plus angle BOC is equal to 180. Hence proof. Next, we're going to say question number 14 from 10.2. Now let's say the question. PAQ is a tangent to the circle with center O at a point A, as shown in the figure. So the figure is given on the right side. And OBA is 35 to find angle BAQ and ACB. Okay, let's take it. Okay, question number 14. So I'm drawing the figure. Now, OBA is given 35, so this angle is 35. You have to find what angle? BAQ, that is this angle. And you have to find ACB. ACB is this, and C is here. Okay, let's first try the given. So there is a circle. So a circle with center O. Center O. Then PAQ is a tangent. Tangent. And angle OBA equal to 35. And to find what angle BAQ and angle ACB. Okay, yeah. Now, first of all, look at the figure. If you see the figure, we know this angle is 35. Now we can find this angle. We can mark it to 1. And how to find this angle? If you see the triangle AOB, in triangle AOB, AO and BO are radius. AO and BO are radius, so they are equal. So in triangle AOB, the two sides are equal. And if the two sides of the triangle are equal, we can take the angles opposite to them equal. Opposite to AO is 35 and opposite to BO is 1. So angle 1 also will be equal to 35. So we'll find 1. And after that, we'll find angle O. After that, we'll find angle O. And after that, we can find C and this B. We can find angle ACB and BAQ. Okay, let's do it one by one. Now, first of all, we know what AO and BO are equal. AO equal to BO. Why? Radii. Radii of the same circle. So we can take angle 1 equal to angle OBA. Why? By isosceles triangle property. Why angle 1 is equal to angle OBA by isosceles triangle property. If the two sides of the triangle are equal, we can take the angles opposite to them equal. Now we can put the value of OBA is given. So angle 1 is equal to 35, then mark it 1. Now, after finding 1, we can find angle O. Why? In triangle AOB, we know the two angles, so we can find the third angle by sum angle property of triangle or angle sum property of triangle. Okay, now before finding angle O, I need some space, so I'll drop the first part. Okay, now in triangle AOB, take some of the angles. Angle 1 plus angle O plus angle OBA equal to 180. Why? Since sum of angles of triangle equal to 180 degree. Then put the values. Angle 1 is how much? 35. We got in 1. Plus angle O we are going to find, and OBA is how much? 35 is given. We're putting the value from 1 and given. Okay, now solve this. Angle O plus 35 is how much? 70 equal to 180. Now solve and find O. How to find O? We'll take the 70 to the other side. So plus will become minus. So angle O is equal to how much? 110. So angle O we are getting 110. So we can mark this one as 2. Okay, now after finding angle O, we can find angle ACB. Look, AB is just like a chord. AB, the chord AB is subtending angle O at the center, and the same chord is subtending angle ACB at the circumference. Now, from class 9, what do we know? Angle at the circumference is half the angle at the center. In class 9, there was a theorem that angle at the circumference is half the angle at the center. So we are going to use that. Now we'll find angle ACB, and ACB will be what? 1 by 2 angle O. Why? Since angle at the center, or at angle at the circumference angle at the circumference is half the angle at the center. Okay, now put the value of angle O. We're putting the value from 2. So on the side you can write from 2. Now cut it. Okay, so on cutting, what are you getting? Angle ACB equal to 55. I will be needing some space, so I'm rubbing the first part again. So angle ACB is equal to how much we got? 55 degree, and we can mark it 3. Now we got ACB. Now we can find BAQ. Now, how to find BAQ? Now look, AB is a chord. AB is a chord, and PQ is a tangent. Now, the chord AB is making angle BAQ with the tangent in the minor segment. And the same chord is subtending angle ACB at the circumference on the major segment. So these two angles are angle in the alternate segment. Angle BAQ and angle ACB are angle in the alternate segment, so they will be equal. Again, angle BAQ will be equal to angle ACB. Why? They are angles in their alternate segments. So we can write angles in the alternate segment. Now we already found out ACB, so we can put the value from 3. And on putting the value from 3, we found out what is our upset phi. So what are you getting? Angle ACB is 55. Same way. Again, angle BAQ is also 55. ACB is 55 and BAQ is also 55.